network for artificial intelligence in the capital region. And we are a little wider group today because we have also asked other networks. We also got a practitioner AI network, and we have asked people there to join us if they would like to have this presentation from Kohn. So we are both more at strategic level, but also at practical level here today. So you're very welcome, everybody. And I would like to tell to you, all of you, that we record this meeting, and we'll put it on our site at the regionh.dk, so that other people can see the meeting and the presentation if they are interested in it. It's not going sort of outside of the region, but it will be recorded. And we are very happy that we have Kohn. And then I must say, Velfas, I guess you're after your last name.
Yeah, that's correct.
Thank you. That's good. And Kohn is data scientist at the large hospital in Amsterdam, and he's going to tell us about his experiences with working with artificial intelligence on an EPIC platform, which we also use in Denmark. And after that, we'll have a small perspective to the situation in the capital region on the Sundheds platform, as we call it, from Anders Christian called Søg Data. And we'll try to make some perspectives to Kohn's presentation. And then we'll have Q&As and a debate. And then we'll close at the latest 5:30. But before I give the word to Kohn, as we have more participants today, and we also are talking English today, we have some new participants, and one of them, Adrian Gabriel Suko, who is a PhD fellow at the Rigshospitalet, would like to make a short presentation of himself. So thank you for that, Adrian, and take the floor.
Well, hi everyone. Nice to meet you all virtually, and I hope that the network is being very productive. I'm very happy to see this because I think it's quite needed in the health sector. So just a bit of my background. I'm a biochemist. I came to do my master's at DTU in bioinformatics, and I started doing deep learning models focusing on interpretability, and that has been mainly my focus. So a couple of years ago, I contacted Jens if he would let me do a PhD trying to implement models in the healthcare system with a focus on explainability. So I think that implementation is really important, but I think machine learning can also be like a very good tool for scientific discoveries, which is kind of my scientific interest and my background. So currently I'm working at the chip at Persimmon. We are using our data lake and also working with some data from SP, mainly on HIV and COVID data. And my PhD is in modeling, trying to explore methods of explainability in survival analysis mainly. So that's kind of what I'm working right now.
Thank you so much for this short presentation, Adrian. I'm a little afraid we did not lose you, Kohn, did we?
No, I'm still here. Yeah.
Okay, that's good. I just lost the image of you. So I will give the floor to you and your presentation, and we've talked about it'll be like half an hour and so, and then we'll have the discussion afterwards. So please, if you're ready to start.
Yeah, I'm ready. Thanks, Kirsten.
Right.
Welcome all. Glad to be a part of presenting about my work. Short introduction. As Kirsten said, I'm Koen Welvaarts. I work at a hospital based in Amsterdam. Mostly work as a data scientist, implementing things or models inside of EPIC, using at this point in time a PMML setup and looking for cloud-based. And just like Adrien, or how I don't know how I said it, Adrian, I also started a PhD quite recently at the start of this month to write some articles down about the projects I did, and mostly the things on the technical side of things that I came across, which were hard for making data science successful in clinical setting, for implementing and, well, successful use. So I would gladly share this presentation with you about custom predictive modeling in EPIC, and more about the case I did with cardiology with Robert Riesebos. He could not be present today, but he sends all to you his best. Yeah, let's get into it. I want to first get into a little bit of background of the case, do a project view to see what kind of important steps there are during such a project you're working together. Also approach from the data science point of view, sort of machine learning, what to use, implementation in hyperspace, and evaluation. So those are my big takeaways for today. I want to discuss, or want to present to you, and I want to discuss on the end, because for me, it is also a learning experience. I'm just trying some things out and see if it sticks or if it works. So this will be much of a learning experience for me as for you. All right. Well, at the OVG, we have obviously a department of cardiology, and the cardiologist Robert Riesebos came to me. He said, well, I want to make a model, or want to use a model that helps me prevent intravascular catheter related infections. So for his patients, mostly heart failure patients, they are quite vulnerable, and that infection could lead to a far worse clinical admission than usually. So we have about 672 of those infections each year on average, as opposed to almost like 17,500 clinical admissions at cardiology. So it's not a big chunk, but 672 infections a year is obviously 672 too much, according to Robert. So yeah, he stated that impact on patient is, well, discomfort, obviously, and prolonged hospitalization. So we saw that the average length of stay was more than double for people with those infections, as opposed to not having an infection. Also, there needs to be a longer antibiotic therapy or treatment. So that is always risky, especially if you're already on a lot of medication and if you're already vulnerable. There's also a high risk of complications due to that infection you already have. So it's like a gateway for other infections. And severe complications such as endocarditis, which is actually a very nasty inflammation of one of the parts on the heart, I believe it, which can lead to death. So that's not a sunny outcome. We want to keep it this way. On the other side, so that's the impact patient. We always make a financial impact, as just take a quick gander at how much is being paid or how much is being treated for this patient on yearly basis, and it's like a big 4,000 euros a patient. Simply stating that on average we have 672 patients. That's close to 2.7 mil average each year. So not only does it have a very high impact on the patient, also on the side of finance, it has a quite of least dent. So we can use, if we want to do something about it, we can use the machine learning to do something more for the patient, and also save some costs, which we can spend on other things, obviously. Approach of the project was actually sitting together with Robert and stating, okay, in very simple and very specific terms, what do we want to do? So we want to predict the chance, specifically the intravascular catheter-related infection during a clinical admission at the Department of Cardiology. So we took all patients of cardiology, and we want to use that risk score, the predicted risk score, to intervene by nurse or attending physician cardiologist concerning the LDA, so the line drains and airways on the patient. And obviously the goal is to reduce that occurrence. I mean, getting it back to zero is never realistic, but getting it back like 10%, I think is more realistic. So getting that catheter-related infections down as soon as possible using the clinical decision support tool. So yeah, for each project, there is definitely always needed for each machine learning or data science project a data scientist, which happens to be me, so check. But there is also a clinical owner that is needed. And why? Because we work together on most of the part of the whole process. So I'll show some other things later on, like the CRISP DM, which is a development cycle I always use. But I think it's making decisions together is really important, because I can make a technical savvy model, I guess. But yeah, most physicians would say, well, I don't know how it works. It's a black box. I don't trust it. I won't use it. So making decisions together from the get-go to the end about how the model works, what should be in the model, choosing algorithms. So developing also and choosing best algorithms, what would best mean for a cardiologist in that case or in that scenario. And also how to implement it into hyperspace, because some people tend to state, well, I only want to show a risk score there, or I want to get a BPA, like a pop-up when there's a certain risk for a patient. So it's really personal. And I think Epic is doing a good job because it's very customizable in hyperspace. So for this case, our clinical owner was a cardiologist, like I stated before, Robert Riesebos. And we had formed a work group for this project with Robert as the cardiologist and clinical owner, with a nurse from cardiology, a couple of infection prevention specialists. So we have a different departments, infection prevention, and they are actually responsible for, well, retaining or doing something about the infections of the patients. We had someone from the quality department, quality specialist, to check upon the quality of documentation and the quality of data, and also the use of data, and obviously a data scientist. So that's kind of a logical move, I guess. As I stated before, it's really important with the clinical owner to work together. Whereas, well, you can easily think of some tasks you need to do during a process. Whereas the clinical owner is obviously the medical knowledge, but what does it contain? So the medical knowledge needed for a project is which patient groups are important, actually, which variables. So most physicians will have up-to-date knowledge about scientific papers to know where causable or causality is on features or variables, so which variables include, but also the gut feeling. So which features or variables do they see have effect, or in their eyes have effect in the real life situation, but are not tested or not proven for causal relationships in scientific papers. So really, which variables do we need also for intervention or cutoff points? So you always deal with outliers in medical data. But yeah, if you want to use certain cutoff points, you are strictly limiting yourself also for the techniques you're using. I mean, if you want to use regression and use outliers, you're going to have a bad time. So you really want to think about that to see if missing values are worth imputing. So missing values is also a common problem in all medical data. I mean, there are always missing values, so how to deal with that. And also, how are models, or is the specific predictive model useful in a clinical setting? So what can they take away, and can they trust the solution that is being implemented? So I guess the clinical owner is responsible to think about that in the as a caregiver or as a medical expert in that field, whereas my role, or the role of a data scientist, is obviously more on the technical part, to search for data, see if it's available or not, and analyze it, do prep and clean for mostly pre-processing for modeling phase, model with algorithms used, up-to-date things, and to see or evaluate how the performance is, and also to implement it in the end if all is well. So usually I follow the CRISP DM, which is fancy for cross-industry standard process for data mining. Data mining is what data science was called. I think like 25 years.
It's mainly for the first, it's only 3 weeks. It's a few days at work.
I guess somebody has to mute.
And they haven't planned exactly which 3 weeks. I think.
Oh yeah, thanks. So yeah, data mining was around 25 years ago, and they called it data science at a certain point in time. But this I use for each project. So you start at left at the top, business understanding, which really translates to what is the problem we want to solve. Data understanding, obviously, do we have data for it? And well, going through that whole cycle together is part of the development we wanted to accomplish together with a clinical owner. So I use this each project, and this whole cycle takes about 3 months, I guess. I almost work full time, so 3 months is pretty feasible. So from business understanding, from going from problem to implementing, deployment actually takes about 3 months. And what I really like about this is not only is it very transparent, so I can state to the clinical owner, to the work group, this is what we need to do right now, and this is what is coming next up. So to draw a line as to, okay, we have all the data, let's go into the next phase, data preparation, or if all data is prepped, okay, let's go into the next phase, modeling. But for me as a techie, it's always very neat to have this for reverse engineering. So I can look up in my log if something goes wrong in modeling, maybe I did something wrong in my data prep, so I can go one step back to my log of data preparation to see where things went wrong, obviously. So for me, it's also a big plus, and to keep it very specific overview. So we used mainly data from Epic, local data and Clarity. That's the relational database that's behind Epic. And implementation is done in Chronicle. So that's the hierarchic database that Epic has, and that's containing all the real-time data, which is really powerful. But always next to that, it's one of the weakest points of the current setup, because the data points need to exist in Chronicle. So if I have a nice data set, and those data points do not exist in Chronicle, I cannot implement it in the current form. Most programming was done in R, also switching to Python more or less these days, because some of the packages do a better job in R. So to each his own. It's actually what you're most comfortable with. And I usually make function files so that my code stays clean. So I have a lot of functions to clean up data, to make the models, and those code I can share actually. So I have a GitHub and I share those functions, because I don't think other people are really becoming happy when writing functions. So if they can use something from someone else, they would gladly do it, as would I. And that helps me recycle code for each project. So in that sense, usually the code is getting better and better and cleaner each project is going. So it's like iterative improvement. So the uses of data was a little bit tricky, because the outcome obviously wasn't documented on discretely. So we pulled it out caboodle using text, well, not text mining, but using text SQL functions. So we look back from going live with Epic, which is actually 15th of October in 2015, looking for all admitted patients in cardiology. And obviously, does the patient have its dichotomous intravascular catheter-related infection, yes or no? And it was actually quite fun, because we would use the contains and the near SQL functions together. So specifying that a text could contain something like phlebitis, which is called in Dutch, but not good, was not combined with phlebitis and leg, for example, because the cardiologist told me, well, if you have it in your leg, that's not the kind we're looking for. So we have around 50 lines of code, so filtering to pull out the infections, and it was almost 92% clean as to containing all the right things. So that's pretty good. So we went with that. We extracted around 39 features. Think about different things like sociodemographic, but also blood work, obviously, but also things like season, because it's, as I believed, easier to get an infection in the summer when there are a lot of environmental things going on. So that was actually quite fun, or size of the needle and stuff like that. So yeah, a lot of things that we included, and we had around 99,000 observations, which were all unique patients. So we had a lot of data that we could use. Well, again, for writing this code, mostly SQL for querying, to pull out the query, make a CSV dump, then parse it through R for pre-processing and modeling, and time spent in R, I guess you could also say that the time was included for SQL, but around 40 hours. So that's not a lot. I guess a work week spent in R, think about which colors to use and how to make nice plots is most of the part, because all functions are already present to pull out and to transform the data in a good way. And that we did, pull out some nice graphs or pull out some graphs. So starting with the prep and clean, we always do a exploratory analysis. So look for, well, in this case, to see what the distributions were. I mean, it's common that in medical data, the distribution is mostly skewed. So yeah, that's something you can take with, or that immediately comes to eye or comes to mind when also looking for outliers, for example. But the base assumption for me is that data is always dirty. It always contains errors, typos, missing. So, and yeah, you want to prep the data or pre-process the data to also which algorithms you can use. So for neural networks, for example, mostly numerics are needed. But for random forest, for example, in R, you can also have nominal data or categorical data. That doesn't needs to be set up or transformed to numerics. So yeah, that's a big part of the exploration that you want to do. Obviously, always looking at outliers. Each feature was evaluated for outliers to see if there was in terms of typos. So some patients had a very low temp and a very high temp, and usually I look with this to these steps with Robert, the clinical owner, and asking Robert, okay, what is actual, and pulling out the medical files or medical charts of those patients to see if something went wrong in documenting, so if typos were made, or is it actual a value or actual high value. So usually my strategy is to replace outliers with missing if needed. And yeah, what to do with realistic outliers, that's actually a question I always ask the clinical owner. Like, hey, do we really need that? Do we really need the model to trigger on that? If so, yes, then I would strongly advise not to use regression for that matter. But yeah, that's shaping your modeling phase a little bit. So that's always is a nice part of the discussion with the clinical owner as to, okay, what kind of data do we have and what do we want to do with it? Whereas I can translate it in technical terms, but he can think about how do we want to model this later on that more. Sorry. So yeah, missing values, that's always a big part. So usually, same as we did with outliers, we look at all the features to see if there are missing variables. Is it worth imputing? But it's also can be very funny because I usually look in clarity, so I know some documentation is a little bit iffy. So you see BMI with missings about, I think, 54%, which is quite a lot. But the funny thing is, or well, it's not that funny at all, is that length is almost present, but epic in the length felt or in the BMI only looks back a couple of years and not since ever. So it makes actually more sense to compute the BMI yourself and take care of those missing. So this is also for me, as a data scientist, a point of looking into my query, into the results, and to see if so much missings were expected or that even I made an error somewhere along the way in writing the SQL query. So this is actually something we can both benefit from the clinical owner and myself. Also making a balanced outcome. So for this case, we had a very unbalanced group. We had the people with an infection was only 3% of all observations, while a major group with no infections was 97%. So yeah, if you train any model with this, mostly the performance will be about 97%. So the model will always learn that or lean towards the major group for training. And if you have a new case, I guarantee that it will more than 90% predict that that patient will not have an infection. So this is something you want to balance the outcome. And actually, you can do that with a couple of different packages or tools. I use Møde. As Møde is something to change the distribution or change the balance in your minor or major group. So it changed it in a way that the major group went from 97 to 76, and the minor group went to 3 to 34%. So I actually did a little bit of work on this myself, because this can be a little bit tricky, or you can get a little overfitting. So this is actually one of my articles that I want to write about at Where Drawing the Line, and how to explain this one. Because in traditional science or traditional biomedical science for writing papers, the balance of the outcome is usually not being looked at. But if you're doing classification, you are gonna have a specific problem if you want to keep a very unbalanced data set. So this is really I found that this was a tough one to explain to a clinical owner, because the clinical owner's framework was that of a traditional regression where outcome of the or balance of the outcome wouldn't really matter. Obviously, feature engineering, choosing the right features. So in red, I circled the features that we included in the final model and all the features that were present. So this is actually mostly to the clinical owner, whereas I'm looking, okay, which do have the most importance or the highest importance. But clinical owner can tell me, okay, I really need variables that do not have a high impact, but I can intervene on, for example. So I can have those variables have impact on the daily basis. So that's actually an interesting part, because then you're getting to talk about cutoff, because usually I use the eyeball test. So I look at where the drop-offs are getting smaller and smaller. So I see a large drop-off here from age to heart failure, and then the next one is relatively seen a bigger leap, and then it goes down a notch. So this was also one for Robert to look at and think about, okay, which variables should be included, because usually, for example, age is always an important predictor or always an important feature, but physicians can't do anything about age. Well, they can let you wait and let you get older, but they can't intervene on it. So they really need some variables or features that they can intervene on, be in the final model. So that's also a very important decision for making impact. So what we did, or what I usually do, is hold a little bit of algorithm fiesta, use different algorithms from simple logistic regression to complex logistic regression like lasso and ridge, which is penalized, simple decision trees like boosted and bagged, and the more complex decision trees like extreme gradient boosting and random forest. So I always look at each project, okay, which performs best or better and at base rate. So usually most of the trees are outperforming regression in most cases. So you see here a string of blue and red, and that's actually the lasso and the ridge regression, and then most like the yellow, orange, pink, green, and turquoise, I think it's are the decision trees. And it's no wonder that extreme gradient boosted tree, for example, the pink line and the blue line for the random forest, is pretty strong. I mean, we've got, what was it, 30? Yeah, we got 39 features. So with outliers normalized. So yeah, I guess that's my experience, that most regression tends to perform less if there are more than 15 features. So yeah, in most cases of the time, for high dimensional data, so a lot of features, and for data with a lot of variance, so a lot of spread, which is also usual, my experience is that decision trees always outperform regression techniques, but more on that in one of my papers also. But yeah, we actually chose obviously the random forest because of the highest performance. So we did a check on that. So I usually run all those models, and this is without hyperparameter tuning. So this is right off the bat, how good does it perform? And the real challenge actually is not performance or getting the highest performance, but it's actually explainability. So obviously, regression is something each doctor or each physician has experienced in his or her lifetime, because they sometimes have a PhD, but sometimes also see colleagues do some regression. Whereas penalized forms of regression like Lasso-Ridge, most physicians never heard of it. Most physicians think neural networks are very interesting, but more like a black box. So yeah, it tends to be a good explainable, or it tends to be good on explaining things when using with decision trees, for example, because a decision tree is something really simple. The concept is really simple, and getting a little bit more on that more complex concept like a random forest is well, it's very explainable to physicians. So yeah, that's mostly about trust, I guess, because if you can't explain it or can explain the big leaps these models are taking, you get a clinical owner or physicians who don't trust the model, and if they don't trust the model, they will not use it. So all your work have been well, practically for nothing. So yeah, that's actually the choices you need to make. We did choose for random forest because it's obviously one of the best performance out there on the models on this case. Everybody understands decision trees. I mean, it's a simple variant on decision trees, making a lot of decision trees at once and work with a voting system to see which decision tree is the best, simply put. So yeah, that's something which was really explainable. But also very important is how safe is it to use in clinical setting? Because these patients who suffered the infection are really vulnerable. So you would like to have a model which has a strong performance to start with. I mean, you can use regression and take granted that maybe 72% of the predictions will be correct. But yeah, if you're suddenly making a model for the ICU, for example, those models are then too weak to use for safe use in clinical setting. Well, that's actually something I always discuss with the clinical owner, how important is the safe use in clinical setting for the model. So how good does it need to perform on a base rate? And usually they tell you, oh, we have nothing at this moment to solve this problem. So no comparison. That's usually most of the time what is happening. And sometimes they have like a score list or some other construct or medium which you can compare your model with. So that's actually quite nice to see how much improvement you will realize. So yeah, on the technical side of things, we implement currently as PML, that stands for predictive model markup language. This is actually a type of extension. It looks a lot like XML, which is a format of Excel itself. I added it in Notepad++ to make it more readable, so to write some text for the interface side. But the biggest disadvantage at this of this platform or of the PML is that the size of the PML cannot be bigger than 4 MBs. If you were to save a standard random forest, it would be like 25 MBs. So getting it less than 4 MB is quite a challenge, and get it to work well. You're always decreasing your performance, but to make it work well with feature selection and also with a lot of hyperparameter tweaking, getting it under 4 MBs is really a real challenge. So that's actually why we as OVG now are looking at the Cloud Foundation Epic uses, because then we won't have that restriction anymore for MBs, but more on that later. So yeah, what I told you, we use the Epic Cognitive Computing Platform license, the ECCP, to parse the XML into hyperspace, the front end of Epic, and use SAR rules. Those are rules that actually you can implement some logic into it for example, pulling out age or pulling out the highest blood pressure or the latest blood pressure, and those are being fed to the model. For calculating a risk score, you have some jobs you have to set up. So the interval for each calculation that needs to be done is around, for example, a default around 3 hours, so that every 3 hours you get a new risk score based on the latest data. And I think that's really powerful because you can change the window of intervention. So you can make it 5 minutes, but you can also make it 6 hours. So it really depends on your clinical case, what the best interval, best window of time is. And yeah, you can use a lot of different things. obviously it's a risk score that's being calculated with percentual risk from 0 to 100%. And you can get this back from the model in hyperspace as a column, but you can do a lot of things with these columns. So you can show it as a column inside hyperspace. So this is in a reporting workbench report, which contains real-time data and pulls out all the data points. And of that risk score, you can make more material to show. So eventually how the risk score is developing over time, and also show a impact by feature, sorted on most important to least important, and what the actual value is. So this actually has two enormous benefits to it. One, the physicians don't have to click through a whole medical chart. I mean, this is data you can find at 6 different places in a medical chart. So this takes about, I guess, a routine physician takes about 7 minutes to find all this information. So it's really a plus that it's all in one place. And also, if they want to intervene, they can see here how the risk changes. So if the risk goes into a yellow zone, or if the risk stays in the green zone, or even going from a red zone. So actually how it envelops over time after taking countermeasures to do something about it. So that's actually, I think, our big two pluses for this one. So you can do other things as well. Usually when I started working out in OVG, I built a lot of dashboards and reports. So I have a dashboard built out for this predictive model. On the left side showing, or on this side showing some analytics. So how many phlebitis or patients do we have with infections? We implemented this in March, which was 28. So you can see in absolute terms that actually those infections were going down actually pretty hard. Relative, it's changing not so much, and that has something to do about this metric because it's using all the clinical admitted people or population in cardiology. So, and also I have specified another metric which I found interesting because this is a primary. So how many infections do we have each month after implementing? But this is stating the average length of stay. So how does it, I mean, if the cardiologist, Robert, stated, well, usually we see a spike, or we see a prolonged length of stay for those people. So the baseline assumption was that if we prevent a lot of infections, you'd see the average length of stay going down. This is a little bit unfortunate because there are some COVID patients in it. So this is, at this point in time, maybe not too reliable, but I think it's a nice gist, and you can see the dotted line, the black dotted line here is around 12 days, which is the average for patients with the infection. So staying under that line is the goal, obviously. Yeah, so we can do a lot of fancy stuff. We can do a lot of modeling, a lot of hyperparameter tweaking. We can do a lot of things on implementing. But the cardiologist said, well, how about those risk zones? So Epic lets you from 0 to 100% state which risk zones are there. How's it with performance, and how's it with the intervention? So usually what we went for in this case, we implemented the model, let it run in shadow. Each score that is predicted as is being read or is being written to Clarity, to the database. And we stated, well, okay, let's wait 2 months, not use it, and evaluate the performance at that point in time. So I pulled out the risk scores for people to see whether this is a good risk score or not. So I did a little bit of Excel, thinking about the risk zones we had proposed. So we firstly had a risk zone from 0 to 40, a medium risk zone from 40 to 80, and a high risk zone from 80 plus. So our assumption was that everything above 80 was phlebitis or was the infection, and everything under 80 was not an infection. So it actually does good on that, on the low and the medium risk, because this tells me the negative predicted value actually predicted correctly how much of the predictions were actually negative. So this is around average 90%, 92%. And that's actually good because those people didn't really have the infection. So in 90+% of the cases, this model was right. I found the higher risk a little bit low, the PPV. This is positive predicted value, and it actually stated that 28% of the predictions made on positives were actually positive. I found this a little bit low, so I started playing around with making a change in the risk zone, going to 90%. But it's actually quite funny because Robert, the cardiologist, told me, well, 28%, he thought it was phenomenal. He said, well, okay, he interpreted this as number needed to screen. So he's like, okay, we have to screen maybe 4 patients to intercept a patient who has a possible infection coming up. So he said, mostly in clinical setting, it's like 6 or 7%. So this is way better than we already had, which is actually quite funny because I thought this was not that good and we had to alter the risk zone score to 90. But he was already very pleased with this based on the current clinical performance. So yeah, that actually was a good conclusion. The risk zones were quite good enough. And then we meted up with the work group for a couple of times to look at intervention. So to make BPAs, to make pop-ups that would be sent to nurses and to physicians, to cardiologists, if a patient has a score of 80 or higher. Also make some columns in LDAs or patient lists where usually nurses work. And which actions to take, because with an infection, it's pretty simple. You can take out the drain, you can clean it, and then insert it anew to lower the risk on the infection. So yeah, this is pretty tight at control. So every 2 weeks, there's a check from the quality specialist in our work group. And she checks every 2 weeks for documentation on the data and uses predictive model also to explain a couple of things. So she really controls this or evaluates this continuously, and definitely making a lot of presentations. So I did a presentation for the nurses, I did a presentation for the physicians, I did a presentation for all the people for the quality department, for example, or a presentation for the infection prevention department. So mostly this is just letting people know, okay, it's out there, we can use it. Maybe it's not perfect, but let's start working on it together, implementing it and making it customizable, that it's working for everybody. So get everyone on board in that way, which led to the conclusion that everybody working now with the predictive model is happy. Also, well, they state that they are happy and using the predictive model, and we observe a decline in occurrences of those infections. So we continue to monitor this effect, and we are going to look in a 6-month window at the next time to evaluate and to see how the model at that point in time works. And we definitely want to take this model and bring it to other departments that also have these kind of infections, to spread it out throughout the other departments of the hospital. So to share this tool. So yeah, that's actually my story. Thanks for listening. I, at this point in time, it's mostly in R code snippets of my work. You can find my GitHub if you type in my name, and I'm always available between Tuesday and Thursday. You can call me, you can email me. I'm emailing is better because I mostly work from home, and I'm always up for working together and looking for response, because there is not enough machine learning going on at this point in time implemented in the medical side of things, I think, or I believe. So I really want to get this into the next drive or the next gear, and to work together with a lot of hospitals to realize this. So yeah, thanks for your time again, and I hope we can look for working together or sharing some knowledge.
Thank you so much, Koen. There's been a lot of applauding to your presentation.
Thank you.
Cannot see it, but there's been a lot of clapping hands. So it's really interesting to hear all those experiences and success also. Before we open for questions and debate, I would ask Anders Christian Risch, you're there and are ready. That's fine. To maybe you can make some perspectives to the situation we are at right now at the capital region using EPIC.
Yes, thank you, Kirsten, and thank you, Koen, for a very, very good presentation. It's impressive to see where you are in the Netherlands. really impressed. I think we can learn a lot from you, looking over your shoulder. And I think this example you showed from the cardiology is a golden example on how a clinical model should be implemented and developed. That you have the request from the clinicians, and then with the clinicians, based on that request, you work out the model and you implement it, such that you have a clinical owner from the very beginning. This is something we are slowly learning in Denmark now, taking the baby steps of implementing machine learning algorithms into Sundhedsplatformen. To take this into perspective to the Danish context, I can say that we currently have one AI model running in Sundhedsplatformen. It's a model predicting risk of no-show at Bispebjerg Hospital at 2 departments now. And then we have 2 main projects we are currently working on that are more patient treatment focused. One is an EPIC developed model predicting risk of sepsis in infections. This is a model, you probably know it, Koen. It's a model developed by EPIC based on American healthcare data. And we are currently looking into implementing this in SP and benchmarking, now that it is trained on American data, how well does it actually perform in Denmark? This is a very interesting case, we believe, because EPIC has quite a wide library of pre-developed models that we can turn on and off. So getting experience with how well this one particular model works can possibly open up a quite big library for us.
Yeah, I can tell something about that, Anders, in 2 minutes. That's where we started. So we are now 6 custom model implemented in the last 2 years. But we started out also using the models from EPIC, started at risk of unplanned readmission. And actually it was quite fun because it's really easy. It's like drag and drop. But the department where we piloted it, it stated, well, this is bogus because my population does not resemble the American population in terms of healthcare profile. And also we need to add some features, add some more variables to it, which are specific to certain departments. And that was not feasible. So that's actually why we went and started with custom modeling. So yeah, that's actually why I'm up here now. So
yeah, but we have actually done a pre-screening, and you're right, there are definitely a set of the models that I absolutely no go in European context. This one we found might be useful, but we'll see. We'll know in a few months, hopefully. The other model we're working on is a model developed in a clinical setup. It's predicting risk of life-threatening infections for patients diagnosed with chronic lymphatic leukemia. Actually, I think the PI, Carsten Niemann, is here today. This is a model developed by Carsten's group, and is currently, we are implementing it into Sundhedsplatformen. The last thing, we are about to take the step of developing an AI model internally and then implementing it into SP. So we're taking the first step in all of those categories currently. One thing we're also looking at right now is, as you also mentioned, Koen, the business model for such an AI model is actually a quite complicated size. You have a clinical perspective, you have an economical perspective, you have a technical perspective. And actually, I have a question: how do you choose your projects? How do you rate the value of each product in each aspect?
So yeah, that's a great question. Let me make it clear that I started in 2018 working on custom models, and at that point in time, I was just taking up all the work I could get my hands on. So after the first model, which was recurrence of strokes, things really got heated up. Things really got busy. So a lot of clinicians mailed like, I got a problem. So the first thing I always look at always have an introductory talk or call, is how many patients does it envelop, not only to get an impact size based on the whole population. So for example, all the clinical admitted patients for cardiology and infections was quite skewed. But I also had physicians who came at me and they were like, okay, we want to predict hip replacements. And those are about 10 patients a year. So I was like, okay, that seems like a pretty nasty problem. What we cannot do machine learning with it. So the first point was to always take a look at how big is the population. Is it in the thousands? Is it in the 10,000? So how many power will I have for my statistical analysis? And I was trained in health economics and statistics. So I usually look at money, and I like to look at money. So I always look at, okay, how much costs are being used for these kind of patients as opposed to other patients. So I make up a scheme which shows the revenue for a department, so to speak. I mean, they're not profited, but how many costs are in it with patients. So then I can see the bigger picture, how much those specific patients we want to solve in the predicting a machine learning or using a machine learning tool, how much would that take care of the whole set of things.
Yeah.
And it's tricky. I mean, we are getting 2 new colleagues, 2 new data scientists at the end of this month. And to be sure, we are looking at the quadruple aim as a tool to benchmark the incoming requests. But yeah, it's tricky because sometimes you have a small problem, but it's really general. It can be generalized throughout the whole hospital. Whereas sometimes, such as the infections problem for cardiology, it's mostly cardiology, but it's a very specific and very clear problem. So yeah, I mean, what you said about no-show, that actually is for all the hospital outpatient visits in the hospital. So that's actually a really big problem. So yeah, it's in that sense about impact. I mean, can you make an impact for the whole hospital or for the specific department? So yeah, we're using the quadruple aim, but it's complicated. Yeah, there's also politics going on.
Yeah, some good thoughts. I have another question. Kirsten, you can just stop me at any point.
Well, maybe I should say that anybody who has a question to Kone or comment, you're welcome to raise your hand, and then we'll make a speaking list. So keep on, Anders.
It's getting back to your cardiology model. I really like that you work close with the clinicians from the very beginning. And my question is about the selection of your feature space. So how did you, well, actually my question is twofold. One, how did you choose the feature space, your input variables? Was it a clinical decision, or did you use some kind of algorithm such as Lasso to choose your feature space? And two, how large a part of the clinical specifications put from the beginning of the project were actually changed during development while you were learning how does the model behave, what is actually possible within the EPIC system and the variables we have available?
So yeah, sorry, could you repeat the second question?
Yeah,
I did not completely understand it.
Well, you can take the first part first.
Yeah, sure. So yeah, usually a clinical owner states to me, okay, we must use these features based on scientific papers, and also that gut feeling I was talking about. So to think about, okay, which features could work. I usually will work with random forest or extreme gradient boosting to see for feature space, feature importance, to make a selection based on that. But it's actually that step comes after the pre-processing. So I want to have all the data nice and spiffy for all the algorithms. But from my personal experience, and also to make it's fairly easy using Carrot, for example, to use random forest and to make feature imp or far imp plots. So yeah, that's mostly user experience. I usually go with extreme gradient boost or random forest for feature space determination.
Okay. My second part of the question was, so laying out the project, I guess from the clinical side, there was some specifications, what target group, what is actually the definition of done on this, the input variables. Did you, during the process of model development, by learning, did you have to change something?
Yeah, now I got you. Yes, there actually were a couple of features that were forgotten. Like, oh, okay, we never thought of that. So sometimes you had to loop back to getting the data and to see if that actually made an impact. So yeah, that it happens. Usually I really state, or usually I really explicitly state, okay, in the earlier stages of the development cycle, which features do we need to use, because it can be really iffy to change features or to add some more features. So to be really clear on that from the get-go, but sometimes it happens, sure. And yeah. I always stay flexible, because I think, okay, it is too big of a shame to not have tested it out if the features that they wanted to add were not added. So I always wanted to put some extra work into it and to see if it's worth extra mile, because most of the physicians will base those choices off of clinical relevance. So what they say will not be like a shot in the dark, but will be a really specific have a specific target. So they actually think about it a lot, and I have to really take it seriously. Yeah.
Thanks. I can see there are other questions now.
Yes, yeah, but thank you a lot, Anders, for your perspectives and your information about the machine learning models approaching the Sundheds platform these days. And then I have two speakers on the list. The first is Carsten Utoft Niemann, and then Stig Egil Boysen. So Carsten, will you answer question?
Thank you, and thank you, Karen, for a very nice presentation. Very exciting to see your work. So I'm a clinician, but also running a research group focusing on developing algorithms for treatment of patients. And to me, it seems that using the EPIC provided interface, you kind of have to restrict yourself and you lose ownership to your model. And I'm quite worried about this part of it, as we are focusing on the life cycle of algorithms. You're currently running a clinical trial using our algorithm to select patients for the trial. So just wonder, what would be your position if you had to start over today? Would you work for the EPIC guided implementation, or would you actually prefer to go for a standalone platform and just providing the code like we're trying to do, like Anna's explained?
Yeah, good question. Thanks. And EPIC, definitely. I would say that I would strongly advise using the cloud solution from EPIC, because then you won't have the restrictive parts which I talked about earlier. But what makes a real difference for me and makes a real difference for all the end users is that EPIC seamlessly works together with interface. So it's with not so many clicks, we can automate a lot of things inside EPIC and make it actually easier for the end user, for the nurse or the physician, to get access to those scores, get access to the actions that need to be taken, get access to the information, or share it with somebody who needs to do something with it. So we saw this with other providers, that they actually have like a web portal that you can open outside of EPIC, and it looks real fancy. But most physicians would state that's too many clicks and too much fuss for me. I just want to see it in EPIC, and I want to actually do less instead of just more clicks. So that's actually the biggest part, or biggest point why I say EPIC all the way. Yeah. And seeing as they invest heavily in machine learning, I actually am confident that they will have a lot of good things that will keep us in a loop for the next 10 years or so. So yeah, I mean, they're a big company, and they can have spent a lot of money on pretty development. So yeah, EPIC definitely. Not sponsored, by the way.
Thank you for a clear answer. Carsten, is that sufficient for you? So.
Thank you so much for the clear answer. I'm still quite concerned about losing ownership, and actually my experience as a clinician with EPIC is that as soon as something is implemented directly into EPIC, we lose control, and we're not able to change it and customize it, and actually have the experience with 50% of my time I spend as a clinician, that Epic forces me to a lot of clicks that I did not want to perform. So I'm quite skeptical about this part, also from discussing with research colleagues at Stanford using Epic. They refuse to implement things directly into Epic due to legal issues and due to the losing the governance of their code and their tools. So,
yeah,
but thanks for your perspective. It's very good to get your clear perspective on it.
Yeah. I am on the whole other side of things, I guess, because Epic is really coming forward to customers who are implementing AI and want to share it, and they're actually providing a lot of input and help. I mean, I cannot state that they always do what they state or do what they tell, but mostly they will definitely, based off machine learning work, do the best things they can. But yeah, I'm a nerd, so for me it's easier to work with computers and more of my daily basis. So I could imagine that for most physicians it's just hassle. Yeah.
But nice to hear the different perspectives and the different learnings. Yeah, thank you both. So Stig, and afterwards after you it's Helle Camilla Strauss. So Stig.
So thank you, Koen, for a very, very nice talk. Really interesting. So I guess my question is more about communication of risk models. So physicians tend to be quite conservative before they change their way of doing things. So do you have some way to communicate at which stage your risk model development is? Like we have in therapy, we have phase 1 and phase 2 and phase 3 studies, and that's a clear way of communicating how advanced or how validated your model is and how well it might implement in other environments or in other settings. So yeah, do you have some comments on that?
Yes, I do. That's actually thank you, and it's actually a very good question, because usually the clinical owner is always the physician who is interested in these kinds of things, and most physicians, as you state, are not so interested in it. So it's actually also the job of the clinical owner to spread this kind of knowledge and this kind of power or tools that we can use to maybe use it. But I also have heard a couple of times that it's not evidence-based. And that's actually a tricky part, because I did a lot of BI work for OVG, for example, for the hospital. And I know that around 65% what the physicians are doing is actually not evidence-based, but they will use it as a criteria or as an argument to not use something new or to look at something new. So that's actually one of the reasons why I also started to writing down in scientific paper format my findings and the model and how it should work for people, the physicians especially, that really want to see evidence-based practice or evidence-based performances, want to see written out. So that's actually a big part, because not all the departments will always be enthusiastic about it.
But sorry, but that the clinicians are now using non-evidence-based strategies is not an argument for introducing another non-evidence-based strategy, I think.
True.
I mean, it's up to you to provide the evidence needed to change the minds of physicians.
Yep. And we're doing a lot of explainable AI, so tools that will use or will make use of the predictive model that you are using and make local predictions. So we make test patients, for example, to show to a certain group of physicians, okay, we have thought about these test patients and the model handles it on this way on a local level, so on patient level. Make use, for example, of ICER or PDP curves or plots to show which ranges and numeric values actually make a difference. So to really on local level explain the model a lot. And that's actually something we are heavily investing in it right now, because Epic doesn't have any tool or any way to show that in Epic. So we really are thinking that we're thinking out a format to use that. So to always make local predictions for patients, for test patients, patients that are real and epic, for most physicians who want to know how it actually is working, how to place the model in terms of evidence-based performance. But it's like ping pong. One question or one answer always gets another question. So it's like sometimes people actually are very skeptical, and it's actually, I think that's a very good thing. But most physicians are luckily pragmatic. So they say, okay, we can use this and we don't know for sure if this will work. So that's actually why we evaluate each model for like this infections model for 6 months and then another 6 months, and to see if it's being used, if it's being still having a good performance and stuff like that. So to keep a good eye on it and to monitor it all the time. But it's definitely tricky. I will not deny.
Thank you. Thank you for the question, Stig, and thank you for your answer, Koen. Now the list is getting a little longer, so it's very nice. Now it's Helle, and then Adrian Tuko, and then Olaf Vendelbo, and then Bobby Lowe. So Helle, your
okay. Thanks a lot for an excellent presentation. I'm interested in your technical organization. Do you have system access both on a clarity level where you would do the feature identification and model development, and also when you need to implement in Chronicles and set up these rules, do you also have the accesses there?
Yes, good question. Thank you. I had a certification training for the clarity part and for development inside of Epic. So yes, I have the rights or the security to go inside of clarity or in Chronicles. But I also have experience and the rights to work on the implementing side in Chronicles. So I'm full stack.
Yeah, so you're not doing handovers to different parties in that process?
Not yet. Maybe with those 2 new colleagues, I can shimmy some of my work to them. But at this point in time, I'm the only one, so I do full stack. Yeah.
Okay.
But it's actually a good question, because there are a lot of security points that needs to be added to your profile before you can go into clarity or before you can go into Chronicles and make rules and implement those rules. So yeah, definitely.
Yeah. Thanks a lot.
Luckily, I was already a nerd before starting on data science.
Well, to me, a nerd is just being very professional, whatever it's being IT or something else. So thank you, Helle. Thank you, Koen. So Adrian, your question, please.
Hi. Thanks, Koen, for your nice presentation outlining the whole data science pipeline. And I have 2 questions. You were mentioning about performance and explainability in that case. Did you have any shift on the AUC when you went from your impute, your augmented data set, to the real probabilities? Because sometimes AUC can play some tricks when you have imbalanced data. And the second question will be, why there's so much interest in introducing causal meaning variables when you're trying to just do a predictive model? Because as far as I understand, you didn't use a causal inference kind of platform. So why there's so much interest in that case?
True. Thanks for your questions. Maybe you can repeat your first question. I'm trying to, or I can definitely answer your second one. Yeah, so most physicians tend to read about RCTs, randomized controlled trials, and those actually can be used for causal interaction, whereas most algorithms I use is just the predictive impact. So the importance of each variable on a predictive value, so not really a causal value. So statistically, that's actually something I want to avoid stating. And I always, because most physicians I work with really start thinking about, okay, we need to include variables or features based off causality instead of just the predictive value. But yeah, it's mostly bound to machine learning, and that's pretty new in the medical setting. So I get that they're not used to it and think about it from causality.
Because I mean, like you could always stratify based on the causal variant, but not really include it if it's not needed, I guess.
Yep, true.
Okay. And my second question, because this I experienced myself, and I think it's common with all the medical data sets, the class imbalance. And I agree that SMOTE is very nice, but I have sometimes some issues with AUC when you have like a high class imbalance, how that translates when you keep measuring AUC in our normal distribution data set. Do you use another metric to support that, or do you just base your reviews on AUC?
Usually when I started out, I needed to balance the first data set that I had. So I tried out different balancing algorithms like SMOTE, but also rows, undersampling, oversampling techniques. And I looked at all metrics that usually come out of a model. So from position, sensitivity, area under the curve, and a lot of other metrics to see what the performance was, to see if I was overfitting or not. Because obviously with heavy oversampling, you're creating the perfect perfect extra observation. So to see if there was a lot of variance or a lot of difference in variance and a lot of difference in the performance of the model. But usually even the minor group can have a lot of observations. So I always tend, I mean, it's arbitrary. I don't know what the best balance would be. I mean, mathematically it would be 50%, but yeah, that's all not always possible. I mean, if you have like 1% next to 99 and 1% is like 100 observations, and you want to make from that 1% 50%, I mean, you're oversampling so much that I don't know if you can call that even your population anymore. Yeah, so that's actually tricky. Yeah.
Thank you so much. I got 4 questions on my list, and the first one is Olav Venable.
Yeah, hi, thank you very much. I'm a cardiologist, a physician, also working with research, and I'm very impressed with the setup that you have. And I have some questions regarding the infrastructure that you have. And it maybe also goes to the participants around the capital region here today. We have Epic, we use Epic every day, and we know there are a lot of data behind. As a clinician, it's very difficult to get access to these data, and it seems that what you showed us today is very impressive. You talk about different systems, Clarity, Chronicles, and Caboodle, and all these kind of things. So, which seems extremely helpful to get the data out. What is required to get this access? Are you solely working for a department, cardiology, or are you within a hospital trust, or how did you organize all these things? Because I think what you do here is actually something you could help us with, but I know you have many other things to do. But we really need a task force to do this kind of things to help the clinicians.
Yeah, thanks, and good to hear from another cardiologist. Getting out the data is like magic for most physicians. So they see the data on the interface, and they know, and they can pinpoint it, and they can make screens of it. To access it from my side of things, you can actually follow a course, Clarity course for certification, and Epic will learn or will then teach you how to access the database, how to get all the data out different places, how to validate it. So that's actually, I think, the first part of your question. There's actually certification for that, and it takes about 2 weeks to follow, and about I guess a month to complete. So you have to do a couple of exams, a couple of exercises, but I would actually advise everybody who wants to get data out of Epic or understand it more thoroughly to follow that. Yeah, I mean, the second part of your question I have forgotten.
Yeah, well, it's it's about the whole structure that you have created. I mean, that there are other softwares. I don't know what Caboodle is, and you have a task force to do this. Yeah.
No, I was a business intelligence developer for the hospital inside the team that takes care of the functionalities of Epic. So that's actually all on premise. and those people are all working at OVG, working with Epic, and make it accessible for all the end users. So I was already inside of most of the teams that work on infrastructure and the framework of Epic on the front and on the back end. So actually understanding that if a doctor pointed out to a certain doc observation or flow sheet list, that I would know, okay, we can pull that out by using this, and then specifying, okay, it's overtime data, so we have a lot of values. Would you like the first, the highest, the minimum, the latest score, and getting in on that timing that most physicians are looking for. Yeah.
Oh, thank you. That's good. Kirsten, do you have any comments on that? Are any people around the table here that can comment on this? Do we have the same possibilities in Copenhagen?
Well, maybe Anders Christian could say something about the course in Clarity and so on. Are there the other possibilities?
Well, yes. I mean, these courses exist, but I think getting hands on data as a clinician is a whole other discussion. Maybe we should take that elsewhere.
I have some queries, SQL queries I can share if you have some questions. So I can share some of my queries or all of my queries to help you out in that part if somebody can access Clarity on your end.
But Koen, this is also a legal discussion, actually.
Oh, the legal discussions are the tough ones. Yeah, but it's a subject we'll keep on discussing and keep on working with to get data out of Epic. We'll take that up. Thank you. And now we got Bobby Lowe, and then Henning Langberg, and then Ivan Olegovic. So Bobby Lowe.
Hello, my name is Bobby. I'm a PhD student within the gastrointestinal field working with the use of artificial intelligence. I was very interested in how you extracted data. A lot of them was laboratory markers, which is relatively easy to pull out. BMI is also relatively easy, but especially here in the capital region, and also, well, it differs between departments to departments, but there's a lot of information written in free text in their notes and so on. I was very interested in, did you do manual searches, or how do you come around these things, especially clinical information, treatment they are getting, when the view of their disease and so on. These are rarely well documented in Epic, at least in Denmark.
Yeah, great question, Bobby. Thanks. So actually what you're asking me, if I understood correctly, how to use free text or unstructured data. And that's actually something I started with on this project because I saw clinical notes, and then I had asked the cardiologist, okay, which clinical notes do we need to include to extract the keyword from? And from that, I actually sat down with the work group, and we talked about, okay, how can we filter out these keywords out of those notes from Epic? So I could make a dump out of those notes with a first try. So SQL statement where like infection, and with some combinations using the SQL functions like near and like contains, which is really nice because it allows you to make combinations of words and also in a different different setting from each other. So you can state that the word no or not a case of should not be farther away from or from infection than 3 words, for example. So you can make a lot of that's actually rule-based filtering, so they call it. You can make a lot of filters yourself. This is actually tedious work, so we did have a full 2 weeks that we looked at the workgroup with this, and yeah, it's just greedy because you're making a dump of the text. Then I would state, okay, these filters were used. Then a couple of other people for the, for example, the quality and the infection specialist would read those texts and put me through, okay, I find these combinations of these words. Then the cardiologist would look at them and would state, okay, this is the infection we want, and this is not the infection we want. And then I would reiterate, change my SQL query till we get the most perfect score. So that's actually becoming a larger part of my work. So I'm at Q3, so starting from July, I'm actually investigating using deep learning to extract those kind of things. So that's actually completely outside of Epic, just using deep learning to extract those keywords and to use unstructured data. So that's I found a way at this point in time which works, but the investments are pretty high in terms of time. So I'm investigating deep learning, and I would really like to share my work through Epic or within your network if I'm finished with that at the end of this year, to make automated searches of that kind of things, because I have the biggest problems when physicians say, oh, okay, I want to use this, and I'm like, okay, where is it documented? Oh yeah, I always write it down in text, and I'm like, oh damn.
Just a follow-up question: were you able to link those in the dates on the notes with the dates on the laboratory markers when they were taken?
Yeah.
And this second follow-up question was now I've forgotten. Sorry. So.
No, I can link the dates. You have this contact serial number, the CSN of Epic for each node, so you can link the right specific node for the right encounter. Yeah. This is also something you learn during the Clarity certification. So no magic there. It's just reading a simple manual.
Well, all of us should just go to that course then, and all of us should get the data, right, Kirsten?
Sure. I guess it's for free. Well, I got two speakers left, Henning Langberg and then Ivan Olegovic, and then I think we'll have to close the discussion because the time is running, and I know that the Netherlands are going to play soccer at 6 o'clock.
And so, win!
Yes, we'll play at 9, so we'll see. So, Henning, if you would put your question.
Yeah, just a small, short question. And I didn't attend the meeting from the right beginning. Sorry, I had another meeting that I had to end first. But one of the things that I was interested to hear is based on one of your answers to a question relating validation of algorithms. So how do you handle new versions of algorithms, and what does that require in terms of validation of the algorithms? So when you have learning algorithms, how do you handle that?
Yeah, so usually for developing models, I use a standard set of metrics. Like I said, sensitivity, specificity, precision, recall, area under the curve, F1 score. And every time I make a model, I reiterate on those metrics. So if I do feature engineering or if we do something else, just testing it out. If you want to get really technical, I usually do a k-fold cross-validation to look if I'm not overfitting on some sort of adjustment I made, because you can always overfit with hyperparameter tweaking on your test set. So that's actually something to take care of. It's actually also depends on what performance metrics the physician wants to see. So not to be to put them in a certain light, but most physicians will also look very heavily to sensitivity, specificity, area under the curve, because those metrics are well known within a medical field of science. Whereas precision or recall, or things like PPV, the positive predicted value or negative predicted value, are relatively newer metrics that physicians will or can use to interpret the performance, but will not always be understood. So it's also what the clinical owner or the physicians will want to show as metrics.
Yeah, but as a follow-up question, how do you handle that? I think that the idea of having, standard patients that you run through the algorithms and look at the outcome to validate it is nice, but do you then repeat that with the new version of the algorithm, or how do you handle it?
Yeah, I usually with each new version I make, I reiterate the metrics. And even when running in production, I always take a quick look. I make a data extraction and take a quick look at the performance metrics. And usually each 6 months, I recalibrate the model, because we usually have more data at that point in time. 6 months in time can mean a lot of data extra to see if the performance metrics are the same, if the feature engineering space or the feature space is the same. So it depends on what you're trying to realize, but yeah, definitely each new version I reevaluate. and I actually wrote some functions because it's a lot of work if you don't have functions for it. So you can just insert your function and just press Ctrl Enter or F5 or whatever your short key is or hotkey is, but then you can standardly reiterate all your performance metrics. So you can build a pipeline for that.
Thank you for that. So let's hurry to the last question. Ivan, if you'll put your question now. Thank you.
Yes, hello. Thank you very much for a very interesting presentation. I work in ophthalmology. We do some deep learning on imaging data, and my question was actually a little bit in parallel with Henning's. I wanted to ask about these. You know, we often talk about static models. You know, you have train a model, you have an output, you can validate it, you can prospectively validate it. Perhaps that's what we as clinicians would like to see, because you know that is our gold standard from when we went to medical school. You know, the prospective clinical studies. And I would just like your opinion or your take on this versus the continuous updates that we can do with the models, because you can, as you say, we can retrain these models ad infinitum. You can, you know, for each month you can train a new model on the newly arrived data, and that's. I do understand that you what you're saying about the standard metrics, but the problem is that if we're talking a little bit further, one step further for some CE marking or some regulatory approvals, it seems to be a little bit problematic, because what the product that you have in a half year is not the product that you have kind of gotten permission to use. How do you think we can solve that? Are there any you know, methods? Do you have any thoughts on how we can tackle that problem?
Yeah, that's actually a good question. Thanks. I think reinforced learning is the way to go. So to reiterate the model or let it become better as more observations are streaming in. But then you would need a place where all the data should go through the model. So a computational space or a server, what do you want to call it? So this is something we're looking into it with now, using the cloud foundation, or wanting to use the cloud foundation of Epic itself, because you can pull the data from Epic to the cloud, pre-process it, and then pull through your pipeline for predictive modeling and use that for reinforced learning. So that's actually something new we're working on, because the current situation does not supply or does not enforce reinforced learning. It's what you're saying is more static. Only part being not static is recalibrating the model every now and then to see if it's still the same. Most in gross lines, it will stay the same. I mean, the goal or the outcome will not change. For example, most features are pretty stable as well. But reinforced learning is definitely the way to go. But then you need a couple of machines or a couple of servers to make a pipeline to get the data and make use of that data to run it through a model and use that for reinforced learning. It's not hard. It's just setup, and with setup comes money and legislation. So that's taking a long time. Yeah.
Thank you. Because currently we do not have any kind of well, let's say political, but you know, regulatory approval will not have any mechanisms to approve such an reinforced algorithm. I think that's quite a problem to be solved, because there are clear positive sides to doing the reinforcement learning, as you also mentioned, and we need to think about, both as clinicians and as mathematicians and programmers, how we can kind of
make it robust,
embrace those types of algorithms.
Yeah, I think the way we started out is the simple way, the PMML way, so very restricted. But it was just to also make business cases so that it would actually become real, become concrete for a lot of people, and to put some pictures on it about impact, about patient impact, about financial impact, to make things look, okay, this is something we cannot ignore anymore. Because we also were heading down that road where you have a lot of discussion about how to set it up. But then the question comes, okay, will it be worth the money? Will it be worth the investment? And if you already have some models working and you can pretty easily calculate what is actually saving you in cost, then it's a lot easier to talk. And also, I mean, you would mostly or definitely you would hit a wall. For example, I'm now hitting a wall because of the restrictive license we use. But that's actually an argument to also show to board of directors, okay, if we use the Cloud Foundation, we get a lot more computational power. So it's improving actually all the models. So that's actually making the talk a little bit easier for you. So, yeah, simply put, just get started.
Thank you. Thank you for your tips and tricks also, Koen. It's been a very interesting discussion to pay attention to, and thank you so much for your presentation. Having a cold, and I think you were very concentrated, and it was very nice to you took the effort to make this presentation. And what I admire is your way of wanting to share and wanting to have a dialogue and have to spread out your learning so everybody can learn more and easily. So thank you so much, Koen. It's been a pleasure, and thank you to everybody who's been here on a summer afternoon at late hours. It's been inspiring, and I hope to catch up on you again somehow and somewhere, maybe in 6 months' time when you have learned a lot about deep learning. And I'm sure, and I know you have some dialogue from time to time with Anders Christian and the colleagues at Syk Data, and it's nice to know that they're sharing there too. So thank you, everybody, and have a nice evening, and enjoy the soccer games if you are fond of that, or enjoy the summer evening. So thank you so much.
Thanks for having me. And if somebody wants to reach out for working together, let me know.
Thank you so much.
Definitely.